I can put you on. We'll deal with
Ones that live in Idaho Falls don't come down.
that. So if it's a day where everything is gonna just be a lecture online, then yeah, they don't come. You just gonna let them know what is or isn't a lecture day, that they can do that. So you've got 4 students online. See if I can-
And your elbow is working.
Yep, was it turning on? That little hoop.
So how do they see this?
So
Just do that.
they can see that. Normally what I do is I have this launched on my computer and then I share my screen. And so instead of seeing a video, they see my PowerPoint. But if you prefer in-person participation, you can just say, hey, unless you have COVID, be in class. But they can at least see you. And can you guys hear Tom online?
Yeah, Miss McKenzie. So my appointment for the screening is during this class on Wednesday, 9:15 to 9:20.
Okay. So Sam,
Mhm.
who's online, has to go do his mandatory screening on Wednesday during this class. So he's just letting you know.
During the lab?
So he'll miss
Okay.
part of that.
So what do you usually do about that when somebody misses a lab? How do they make it up?
I either have them get with students to get the notes and do whatever assignment they were supposed to submit, or do a makeup time, or he's just gonna walk across to read and come back. So he may
So,
still have missed
okay,
10 minutes.
or was he, I guess he lives in Idaho Falls.
No, he lives here. So there's a few people who are online today because it wasn't clear if they had to finish screening before coming to class. That was the biggest thing. So Sam and
Honestly, I would. At a class, but.
yeah, that's your call.
Yeah.
With the COVID
Well, 'cause
stuff?
it's gonna be, I'm
May
gonna,
not be available.
I won't talk to you about the rat sources I'd like to bring down.
Okay.
So it's hard to make that up, I guess.
Hey Sam,
Yeah.
can you take a look and see if there is any opening, because that's not that, because Wednesday is gonna be a lab.
I actually had a question about that too. So I did receive an email about the COVID screenings, and it says you could go back to class immediately after your screening appointment. So it says you could be in class before it, and that I just want clarification from administrative kind of standpoint.
Sorry, say that one more time, Sam.
So I got an email from the school, and it said you could come back to class immediately after your screening appointment, which
Yeah.
kind of implies you're not supposed to be there before your screening appointment. So I don't know if there's something like an email I never got, or like if it's a gray area or what.
No, so the screening is only for people who are asymptomatic. So you can come to class before your screening, and you can come to class after your screening before you get your results.
Okay.
But Tom is saying that the lab you guys are gonna do Wednesday, it will be very hard for you to leave partway through and come back. So I'm just wondering if you can move that appointment to any other time other than that lab on Wednesday.
Yeah, I'll try to find a slot real quick.
Okay. Okay, so the people online can see you and hear you, Tom.
Okay.
And I'll just leave my laptop for you, and we'll talk about the sources after that.
Sounds good.
Do you need anything else from me?
I don't think so. It sounds like seems like I'm working, so good. Thank you. Ken.
Okay.
See you later.
Thank you.
Is this everybody? All right. Well, good morning. My name is Tom Clausen. And,
There's markers if
So-
you want, but I don't think you.
on the
It's
screen.
on your syllabus.
Yeah, it's on your syllabus, so y'all got a copy of the syllabus? My email address, oh, it's right. Did you
No.
change? Oh, I changed.
It's
This is the
Thomas.
one I did, yeah. So I made one.
So
And
his,
then
yeah,
I'm not looking at the one you
that
gave
was
me.
printed before we
Yeah.
actually got his email approved. So it's Thomas Clausen, not.
So, yeah. So Thomas Clausen at isu.edu. I'm not set up yet, so I understand that's gonna be my email address. In the meantime, that Tom Clausen that's on your syllabus, Tom Clausen at me.com is my personal email address, and in the meantime, you can use that if you need to get a hold of me for something. So, I guess this is ESET 250, radiation detection and protection. So what I'd like to do first off is just kind of get to know who you are, and I'll kind of start by who I am and my background. So again, my name is Tom Clausen. My background's in more of the health physics, radiation safety end of the world, and this is not my, I guess, my regular job. I own a business in Idaho Falls that does radiological, I guess, training, consulting work, primarily in Homeland Security, kind of counterterrorism type work. And so we have about 15 employees scattered throughout the United States and in Idaho Falls, and then New York, California, that support a lot of Homeland Security type stuff. We are a NRC, Nuclear Regulatory Commission licensee, so we have radioactive material sources and do a lot of, my whole career for the last 20 years has been training primarily law enforcement and military. But prior to that, I worked in the nuclear industry at commercial nuclear power plants all across the country at different plants. So radiation protection is kind of the majority of my background. I know a couple people, Christy and Jennifer, I met when I do trips to Chernobyl. So some of you are probably familiar with that trip that took place, and Mackenzie went. And so that's our company that does that and hosts those trips over there to Chernobyl. My goal really is for you folks to just come away from this class and really have a really strong background understanding of radiation detection and protection. So I know radiation protection is not really the focus of your the path that you're going in school, but I think it's important just to understand, if you are working with radiation, how to protect yourself from radiation, and how to just understand what the biological effects and things like that are. Personally, a little about me, I've got 4 kids and I live in Idaho Falls. I like to travel and outdoor stuff, snowmobile, things like that. Christy, you want to?
You guys all know
Everybody
who
knows
I
you,
am.
right?
I just graduated with my bachelor's degree in December. Thank you.
Hoorah.
I got to go to Chernobyl with Tom in October. So I'm a teaching assistant for Mackenzie this semester. We've, I think, made some upgrades to Moodle. I don't know if you've noticed, but like on the side, it has the week now, so it's easier. You can just hopefully click on the week and get to where you need to go faster instead of scrolling. I can't remember the other things at the second, but Tom actually hasn't even gotten to go into Moodle, which is why I'm kind of in here today. And then I'll be helping with your labs with Tom. I think most of them are going to be over in the new lab basement down in RSC. So, and you guys know I have 4 kids and life is crazy. So good, but anyhow, to tell. This is more, you guys know each other. This is for
Yeah, this is for me. Please tell me. What I'd like to know is just tell me, I guess, are you all in the same program, all the same major? Is that right? Okay. Maybe why you decided to choose this field, and then just tell me just something about yourself, something personal, or whatever you want to. Favorite food? I don't know. Something about you, unique, whatever.
I could tell. And back in the day, I actually worked for PG&E in California, and I had an interest in energy. That I have 3 children,
Yeah.
and really didn't continue my education at the time. And now it's my turn. So I'm sort of doing what I wanted. I tested in for this program. Originally, number 1 was horticulture, and that wasn't really going to pay my bills here. So
Yeah.
I really love it. It's been like this at times. wondering if I'm in the right field, but I'm in the
Yeah.
right field, so.
Good. And tell me, your first name is?
To tell.
Catalan is cat,
It's Mass?
Yeah.
like cat L.
Okay. All right, great. And so you work in the energy sector in California?
Many years ago.
Very good.
Other than that, I was basically just a stay-at-home wife and a farmer, and I have livestock, horses, and
All right, all right.
lunchtime, love to hike, do outdoors.
Okay. And so did you work, was it a nuclear place where you worked or?
No, I was actually started at PG&E as a meter reader, and
Oh.
then I did some mapping.
Uh-huh.
And checked up with the maps for all the routes.
In what part of California?
Central, Paso Robles, Templeton, we actually lived in Templeton for a while. That, like, Eric, the Paso, Templeton, Paso Robles, pretty much for most of my life.
Okay. I was born in LA and raised in San Diego, so
Yeah, familiar with that
my
area.
parents are from Idaho. So my dad retired from the military and moved back. That's where I grew up, was in California, in DC. Very good, all right. Jennifer.
Jennifer, you spent a significant amount of time together last year.
We did.
I'm going through this program because I wanted to switch gears in my life. I was a construction worker for a long time and wanted to do something else. Graduating this semester with my Bachelor of Applied Science from this course, taking a bunch of health physics classes, and I'm actually working in the EAL lab. Semester.
So you have taken some health physics classes?
Yeah.
Before Chernobyl or after?
During
Oh, okay.
and before, and I might go and try to get my bachelor's in health physics. It's super interesting.
It is. Yeah, very cool. Well, good. I enjoyed the time we got to spend together in Chernobyl, that's for sure.
I don't know.
She's kind of mean, but I learned that she's got a very big heart.
I'm Lynette Godfrey. I've lived here in Pettisville my whole life and raised 3 children, and life circumstances changed and decided to come back to school. And I had an internship out at INL
Mhm.
This past summer, and I loved every minute of it.
And so that's what made you decide kind of to go in this path?
No,
Oh.
just my circumstances in life changed, and
But I mean,
and-
why did you pick this tech, the sort of nuclear?
Well, it was funny
Because of the
because
INL,
I
or?
did a program called the START. It's a START program. It helps introduce people back into school.
Mhm.
And they have you do like a math test, and I scored high enough, and so I decided to check out the STEC program.
Oh.
And I just thought this would be a great program but I had no clue what I was getting myself into when I
Yeah.
first started. But I've come to enjoy
Oh, good.
the
Yeah,
program.
it's different going back to school if you've been out for a while, huh?
I
I know, yeah,
long time.
right, yep,
Yeah.
very good.
My name is Joe from Pocatello. I chose this field because it's a STEM field, something I've avoided most all my life.
Mhm.
Nuclear energy, I also feel advanced technology is pretty much the only hope for the human race.
Yeah.
I kind of wanted to be involved in it.
Good, all right, Joe. Next.
I'm here with disabilities and note taker.
Oh, okay, very good. Hello, no ticket.
I'm Amber. I'm from Idaho Falls, but I live in Pocatello for school.
Oh,
right
okay.
now. And I started this program because, I don't know, I wanted to do something cool. And I thought this was cool.
Well,
Yeah, they're pretty awesome.
I agree. It is a cool field.
I'm Haley. I have 2 kids. My sister took the WT program, so when I was deciding what to go back to school for, she said I'd be really good at this, so that's why I came here.
All right.
I'm Kyle Moser. Meet you all.
Yes, thanks for doing this for me.
Yeah, I have 2 kids, and lately I've been kind of boring. I don't really do much now. I got 2
I understand, yeah, I'm four, so I know what that's like. Some of mine, 2 of them are grown, but I still have 2 at home. Well, 3 at home, actually, power twins home right now, so. All right. And then our onliners.
You guys want to unmute one at a time and introduce yourself,
Let's
guys?
just call him Caden first, maybe.
Oh, Kaden. Can you guys still hear us?
Yeah, we hear you.
Okay. Well, Jack, you're on. Let's.
Okay, I'm Jack.
Hi, Jack.
I live in Idaho Falls, and I decided to do this program because I wanted to work at INL. And after doing a little bit of research, it kind of seemed like going into operations was something that would be that I was interested in. So then I learned about this program at ISU and signed up.
Okay, very good.
Can you hear me?
I can.
Hi, so I don't have a camera on my desktop, but
Oh, okay. Hi, Caden.
Aiden, I joined this program because I found it really interesting, and I like the hands-on type of thing you could do at this program. And yeah, I'll be in class next time. I didn't know we could come in without our screenings already done, so.
Yeah, no worries. We'll get it figured out here.
I don't know why it's not.
All right, so Caden, you live in Idaho Falls. What made you choose to go into this?
I live in Pocatello, but I chose it just because I thought it was really interesting, and I like the hands-on. I learn better that way.
Well, good to know. Okay.
Hi, my name is Sam. Can you guys hear me?
Oh, Sam.
You want to can you turn your camera on, Sam?
No, I can't.
Okay.
I hear you. We can hear you, Sam.
Yeah, so my buddy Marcus, or why I came to the school is Marcus, one of my buddies, came to check it out, the program. And I came with him, and we were just like, yeah, let's do this program. That's why I'm here.
Okay. Very good.
And then on the computer, on the big screen, you have to push something and then it'll come up.
All right, my name's Porter. I live in Idaho Falls. Decided to do this program because I've seen the success my friends and family have had at the site.
Right. Just in general at the site, or did they go through this program as well?
A few friends that went through this program. Specifically, yeah.
Good. All right. Well, anybody have any questions of me before we kind of jump into the syllabus next, I guess, at least go through that. Let me,
I have a question.
did we forget somebody that was online?
Go, Jack.
I was just curious, are you going to prefer that we're here for the lectures?
I would prefer that, actually. Yes, if possible. That would be my preference.
Okay, that's fine. I just wanted to know going forward.
Yeah, no problem today. But that would certainly be my preference, is to have people actually here if we can do that.
See, this one is still reading your computer. I don't know why.
Well, I just hooked mine in because I need to use mine for this. Is there a reason we wanted hers hooked up?
Well, it would, no, yours is showing on there.
Yeah,
Never mind,
yeah,
sorry.
it should work, hopefully.
His is,
Haley?
yeah, his is just
So
covered.
since he prefers to be in class, are you still gonna have the availability to log into Zoom if we're not able?
Yeah, I will. I'll get all this figured out. I mean, I have not even been, I understand that I have an email address, but I've not gotten any of my credentials or anything so that I can get into Moodle or any of that stuff. So Christie's helped me get stuff for this first week at least loaded into Moodle, and I'm completely unfamiliar with Moodle, so I'm gonna have to learn that and be relying on Christie for some of that. So, but again, my goal is for you all to get the most out of this class. So please don't ever hesitate to email me, whatever, to get a hold of me if you have any questions at all. Because I want you to succeed in this class. That's my #1 goal. You know,
I just want to confirm real quick that every Wednesday will be lab. Is that correct?
That's the plan. So next week, since Monday is a holiday, I plan to use next week's lab day. We'll meet in here and actually do lecture. But for the most part, we'll try to do Wednesdays as lab days. Unless there's a reason we can't meet on Monday for the didactic or lecture portion of the class.
Perfect. Thanks.
Okay. And you know, I'm gonna try to work with everybody. You know, my preference would be that you're here, but if you know, if something I understand that, you know, a lot of us are non-traditional students here, and life happens with kids, whatever. So if that's the case, just let me know. You know, I'll work with you. I'm not gonna be a jerk about it or whatever. So let's go through the syllabus. I know the folks that are online, were
Yeah,
they
it
able to
should be
get on
this
Moodle?
close to the
Okay.
top. They should be able to access.
So I'll just kind of quickly go through this. The course description objectives, like I said when I first came in, radiation detection and protection. So the big focus of this is to get you to understand, you know, what radiation is and more about radiation, and how we detect it. And then from there, how to protect ourselves from that, biological effects of radiation. Course materials, we've got the book here. We're not going to get through, the soft cover hardbook. We won't get through all of the book, but I think the stuff that's most pertinent to radiation detection and radiation fundamentals and radiation protection, we'll get through. And these chapters are really short, but I'm looking at like chapter 1 and 2, and I could spend, you know, a week on that almost. So I'll go into definitely more detail than what's in the book, but I'll give you all of my notes will be, or my PowerPoint presentations will be on Moodle, and then I'll upload some other material on Moodle too, so that if you want to read and get more detail on a subject, you can do that. And again, I'll help you however I can if it doesn't click or make sense. And then a scientific calculator. We'll do some stuff with radiation decay calculations and inverse square law. I don't know what your background is or how much you've learned up to this point. So, but we'll get into some stuff where we'll use a scientific calculator as well. And then Moodle, like it says in here, I'll use Moodle to post things and homework assignments. We'll have quizzes that'll be on Moodle. Attendance, it says attendance at all lectures is generally necessary for success in this course. So you can see it's kind of weasel worded there. I'm not making it mandatory, but my preference would be that you be here if possible. Homework will be assigned on Mondays and will be available on Moodle. So we'll have Moodle quizzes. Christy's helped me with a couple of quizzes already, so those will be on Moodle. And we'll talk a little bit later about kind of how that works. Reasonable accommodations for students with disabilities. So if you have disabilities, just let me know, and whatever we need to do to accommodate whatever the situation is. I want to be very accommodating to everyone and make sure that you succeed in this class. Code of ethics and academic dishonesty. I think that's probably pretty boilerplate for all the classes. You just want to, do your own work. You're in this. Motivation is a little different than high school students or something like that, right? You're doing this because it's your career. You want to be better, so you need to learn this stuff and you need to know it. So please do your own work. Electronic devices policy. Basically, silence your cell phones. Please don't be on social media. Pay attention when you're interacting with class. Please, be present. It hurts my feelings if you don't listen to me and you're just on your computer. All right. And then course content. We've got a schedule here. This is, of course, subject to change. It's kind of hard for me to, building this, not knowing what you all know and what you've learned up to this point, how long some of these subjects will take. We only have less than an hour to get through this stuff. So you can kind of see the stuff that we want to go through, the structure of matter and radioactivity for a couple of classes. And then we'll get into radiation units that are important in dosimetry, understanding what radiological units are. Then we'll do biological effects, the system of radiological protection, and then we get into the actual rad detection and measurement in a couple of lessons. And we'll be doing labs with rad detectors, and actually, my plan is, because I'm an NRC or Nuclear Regulatory Commission licensee and have actual rad material sources, my plan is to bring those in and let you actually do surveys. I actually graduated a long time ago from the College of Eastern Idaho, back when it was Eastern Idaho Vocational Technical School, in a program similar to this, but it was a health physics type program. And when I got out, that was the thing that was lacking, in my opinion, was, we knew how to use survey meters, but we never actually surveyed real rad sources. So you didn't get a real feel for what it's like to detect a very hot source and how quickly it drops off as you move away. And so I wanted to be able to give you that opportunity to see that and to kind of learn about the inverse square law from actual sources and things like that. And then again, when we've got those holidays, we'll probably switch the lecture portion to the Wednesday. And then I'll try to do all the lectures, the lab stuff on Wednesdays. So I definitely want to have you in class or in here for the lab stuff. And then we'll go into the external radiation hazard. So how we would protect ourselves externally from a radiation source. And then we do the internal radiation hazard. So if you ingest radioactive material, what happens when it gets inside your body, and what can we do about that? How can we get it out of the body, or how can we protect people from getting rad material? And then area monitoring would be, how to conduct smear surveys, wipe samples, rad surveys. We'll get a little into posting, what contamination areas should be posted like, what a radiation area should be posted like. And then oral boards. So I don't know how you all feel about that, but I can tell you how I would have felt about that when I was a student, or how I did feel about that. So trust me. In fact, when I took my first job, one of you said, kind of, I don't know who it was, that sort of, wanted to do this and forced yourself into this stuff. It might have been Joe, maybe something. I took a job at the College of Eastern Idaho. I worked there for 10 years, and I started as an instructor, and I wanted to move back to Idaho. I traveled all around the country. I was like a carny. I lived in a fifth wheel travel trailer. I worked 7 days a week, 12 hours a day at nuclear power plants all over the country. And I wanted to move back to Idaho, so I took a job teaching rad worker training for people who worked at the site. And I was horrified. I couldn't even, when I was a rad tech, if I would have to brief 2 workers on an RWP, a rad work permit, and say, okay, we're going to go in, and I couldn't even sleep the night before knowing I had to talk to just 2 people. So I was horrified. I had to do oral boards when I went through a Navy 108 training after I got out of school. Then Navy hired me as a civilian, and we had to do oral boards, and it was just, I was horrified. So trust me, I get it if that's you, but we'll work through it. We'll practice. And the reason we're doing oral boards, if you go to the next page in the syllabus under the course requirements, it talks about the oral boards. Since you're going to have to do that for NRC licensing exams, and then it's also one of the, what is it, the ABET accreditation things was the oral boards. So if we need to do some practice ones in the lab time, whatever we'll do, I want, again, the focus is you guys and you folks to succeed. So we'll do whatever we need to do to hopefully make you get comfortable with that. Course attendance, if we look at the requirements on that syllabus, attendance is 10% of your grade. Okay, and that doesn't mean just sitting here. I want you to participate, ask questions, participate in the class. Assignments, there'll be handouts, Moodle quizzes, things like that. So those quizzes will compromise 15% of your grade. And then how we're working that is you'll have 3 attempts to take a quiz, and your scores will be averaged. And the reason I did that is just so you don't, I don't need to study, I'll just take it, and if I fail, so what, I'll just take it again. So if you get 100% or 50% the first time, and then a 75, and then 100, we take those 3 scores and average them, so you would get a 75%. So try to do good on the first attempt, but if you don't, you can get another attempt, and we'll just average the scores, and you can take it up to 3 times. Oral boards, we talked about, that'll be 25% of your grade, and then we'll have a midterm and a final. That will also be worth 25% of the grade. And again, hopefully those will not be difficult if you get the stuff that we're doing in the class and quizzes and if we need to do kind of practice exams, we can do that. So again, focus is success. So then you got a chart there that talks about the points available and the percentage of your course, and then the grading criteria, grading scale that I think is pretty standard. And then the rest of the stuff is kind of boilerplate stuff. We've got the COVID policy that's just the school's COVID policy. Any questions on that? Okay. Well then, we'll jump in.
So I don't know if this will record on here.
Oh, and will they have it in Moodle
Yeah.
since you put it in Moodle?
Yeah, so you guys online pull up the PowerPoint because we have 2 different computers plugged in today, so.
Yeah, I apologize that for you online people that, because I don't have my access yet, I'm not able to record this in the way that hopefully I'll be able to in the future. So if you go into Moodle, you'll see the RAD fundamentals type review PowerPoint that Christy put in there. So if you just want to open that, you can go through that, and that's what I'm going to go through. And again, the purpose of this is just to, I think it's going to be just a review, I hope, of the EST 153, which is what kind of the GERT rad worker type stuff. Is that right, Christy?
Yeah, they mostly did stuff to take their rad worker.
Yeah. So hopefully this stuff is all a review for you, and we'll do our lab on Wednesday. I'll kind of be focused on some of this stuff here. So. All right, so our review. Everything's made up of atoms, right? And atoms are made up of protons, neutrons, and electrons. So what can you tell me about protons? Positive charge. Where do we find them? In the nucleus. What do they contribute, or what do they determine for the good. Yeah, so that determines the element, the identity of the element, what it's going to be: hydrogen, helium, lithium. So the number of protons changes, the element changes, right? And then neutrons. Okay, tell me about neutrons. Neutral. Okay. What do the neutrons determine? The what? Isotope. Yep, the isotope. And kind of the nuclear properties. What happens if we have too many or too few neutrons for a given number of protons? Unstable. Okay. So again, we're going to get into all this. I'm just trying to get a feel for where you all are at. But the next lecture, we get into more detail. We'll kind of dive down into this stuff, and it may be a review for you, but we're going to work through this book. But I want to make sure that everybody really understands this, so when we start talking about rad detection and measurement. So yeah, they determine the nuclear properties, because you've got the protons in there to determine the element. The nuclear properties are determined by the neutrons. If we have too many or too few neutrons for a given number of protons, then that atom will be unstable or radioactive. And then electrons, where do we find the electrons? Out in the shells. They revolve around the nucleus, similar to the way the planets orbit the sun. What do they determine? Anybody know?
The energy level of the atom.
Okay, the energy level of the atom, that they will determine the chemical properties, largely, right? Because if an atom needs electrons, it's going to bond with other things. It's going to, or it's got maybe too many inside our shell, or it can share with others. So it'll kind of determine how that will bond with other atoms to form molecules, compounds, and things like that. Okay, and so it says here, not all atoms are stable. Unstable atoms are known as radioactive atoms. Yeah, quicker. All right, radioactive decay. So unstable atoms will undergo radioactive decay to become stable. I swallowed wrong, I don't have COVID. But, so we talked about these neutrons, too many or too few neutrons for a given number of protons. If that happens, then what they want to do is they want to stabilize. So are you familiar with what happens if there are too many neutrons? Do y'all know that? Okay, it'll be excited, but how will it transform if there's too many neutrons? Anybody know? If you don't, that's fine, because we're going to get into it. I'm just trying to, if you did know, I might be a little worried that my lessons for the following weeks that I've developed. Exactly. So a neutron can become a proton can become a neutron. So that's part of this radioactive decay. So that's what's going on. If there are too many neutrons or too few neutrons, it wants to become stable, and so it can convert a neutron into a proton or a proton into a neutron. And when that happens, it's giving off this excess energy in the form of particles or rays. And that's what allows us to detect radioactive material, is this radiation that's given off. So that's why understanding this becomes important from a radiation detection perspective, is because we need to know what's going on inside this nucleus and what's coming off. If I'm seeing an alpha particle, what does that mean? Or if I'm seeing a beta particle, what does that mean? So a beta particle comes from a neutron that's converting into a proton. So you kind of understand what's going on. And again, we'll get into all this. During decay, this atom releases energy in the forms of particles or rays called ionizing radiation. And ionizing radiation is what allows us to detect radioactive material, but it's also what makes it hazardous. It's what causes it to, or allows it to do damage to our body. So because of radioactive decay, we're able to detect radioactive material. The radiation produced by radioactive decay can only be detected by special equipment. So we can't feel it, we can't taste it. And you sometimes hear people talk about in a radioactive material accident, I had a metallic taste in my mouth, some of the Chernobyl. How many of you have seen the Chernobyl series? Not everybody, huh? Or has anybody not seen it? Yeah, the series. Has anybody not seen it? Okay. That's pretty good stuff. All right. So the amount of time for a given isotope to lose half of its radioactivity is known as half-life. So we talked about radioactivity. It's unstable. It's giving off energy in the form of particles or waves. That's radioactivity. An unstable atom will eventually decay to a stable element. However, this process is often drawn out. It can be over a very long period of time, and it's not just a single step. Some things decay one time, and then they're stable. Other things, it's this series decay, as it's called. And these half-lives can range from anywhere to a fraction of a second to millions or billions of years. So technetium-99M, Tech-99M, is an example of a very short-lived radioactive isotope. Anybody know what that's used for? Tech-99? It's a probably the most widely used, what we call radiopharmaceutical, is Tech-99. They inject it in, if you've ever had a treadmill test or a heart stress test, it's very commonly used for that because it has a short half-life. Gastric emptying test where they'll actually give you some radioactive food to eat, and they can image your stomach to see how long it takes for the stuff to leave your belly. That's this isotope. Thallium, 3-day half-life roughly. That's common for heart stuff. Then you've got cobalt-60, widely used in industrial applications for food sterilization, for cancer treatment. That's got a half-life of about 5 years. Cesium-137 has a half-life of roughly 30 years. So that's a very prominent, predominant fission product. So after a reactor accident, that's the predominant long-lived isotope that you're going to see. So when we went to Chernobyl, what was the most common isotope we saw? I took some isotope identifying instruments that'll actually tell you what the isotope is. So there's some instruments out there that's pretty cool. You hold it up against the source and it tells you what it is. Oh, this is cobalt or this is cesium. So we saw a lot of cesium, a lot of cesium. Brooke, I think it was Brooke, found plutonium.
There's no plutonium.
What's that?
There's no plutonium.
That's right. So everybody knows Brooke, right? And there's Brooke Johnson. So she was borrowing one of my detectors and got a reading of, she said, oh, I found plutonium. And one of the people there heard her say that, and I got called into the director's office, and he told me that we did not find plutonium. We'll tell you if you find plutonium. So, but yeah, that's right. It's not plutonium. So you can see some of these things are very, very long half-lives. Uranium-238, which is a naturally occurring material, the half-life of 4.5 billion years. So these half-lives are very unique. It's like a fingerprint in a way. They're unique to each isotope. There's nothing we can do to speed up that half-life or to slow it down, heating it, cooling it. If we could figure out a way to kind of speed up that half-life, you'd be very wealthy, because that's really, when you look at the nuclear industry, that's one of the main problems we have is the waste, right? That it's radioactive for so long. You look at the accident at Chernobyl that happened over 30 years ago, and you've still got this huge exclusion zone that's uninhabitable because primarily it's cesium and strontium, some of the other long-lived isotopes. Fukushima, same thing. There, now that some of those shorter stuff has decayed off, cesium, it's going to make that area uninhabitable for a very long time. And so there's really nothing we can do to speed that up, and that becomes the problem with radioactive material. So when we talk about half-life, that's the amount of time it takes for half of it to go away. So if I had a thing of radioactive material, after one half-life, I'm going to have half of what I had, right? So if that's 5 years, 30 years, whatever it is, I'm going to have half. After the second half-life, is it all gone? No. So that's a lot of people think, oh, after 2 half-life, it's gone. Then it's just half of a half or a fourth. And then a half of that half, or an eighth, and the 16th, 32nd, 64th. So after 7 half-lives, you're down to less than 1% of what you had to start with. So usually, when you think of radioactive material, after 7 half-lives, a lot of times it'll be, for the most part, gone, depending on how much you had to start with, right? So it's less than 1% after 7 half-lives. And after 10, that's usually when they consider stuff, for the most part, to be decayed away. So if you look at Chernobyl, we're 30 plus years into it. We're only 1 half-life for the cesium. So 7 half-lives is over 200 years. So again, that's the problem with radioactive material, is this long half-life, and it makes it difficult to get rid of stuff. So we talked about the decay chain. Uranium goes through this series decay, eventually getting to lead-206. So radioactive uranium will eventually turn into lead, and that's kind of a shortened version of the actual decay chain. So uranium will decay to thorium by giving off an alpha particle. So because an alpha particle contains what? What's an alpha particle made up of? Do you remember?
Isn't it protons and neutrons?
Yes, exactly. 2 protons, 2 neutrons. So you notice the mass number changes by 4 here, right? Again, we'll get into this in the next lesson or whatever. But so you see here, alpha, beta, beta, alpha, and so it changes. So radon, which is a very common thing you hear about, comes from the decay of uranium that's naturally present in the soil. So that's where radon comes from. It's in this uranium decay chain. Bismuth, lead, polonium, all these things are part of this decay chain. Polonium-210, that's what was used to assassinate Alexander Litvinenko, the Russian spy. They used plutonium-210 to kill him. They put it in his tea and killed him with, he died from the ARS, or acute radiation syndrome. So that's part of the uranium decay chain. All right, when I say the word radiation, most people think of the type of radiation we're talking about, which is ionizing radiation. So we got this energy spectrum here, very high energy. I'm sure you all know what that is. Has the ability to cause damage. There are 4 main types of ionizing radiation that everybody's familiar with, that hopefully you're all familiar with: alpha, beta, gamma, and neutrons. Which one is stopped by paper? Alpha. Okay, the next one here, it shows it goes through paper, goes through aluminum, but it's stopped by concrete. What do you think that'd be?
Gamma.
Gamma. And then this one goes through paper, but stopped by aluminum. Beta. And then this one goes through paper, aluminum, concrete, but stopped by water. Neutrons. So hydrogenous material is used to shield neutrons. All right. So how do we protect ourselves from radiation, from the external radiation hazard? Time, distance, and shielding. So this is kind of a fundamental law in radiation protection, right? Time, distance, and shielding. We minimize our time. We use whatever shielding we can, get as far away as possible. We'll spend some time and talk about distance and the inverse square law. Do some lab work with that and let you actually see it. This is a very, very important thing to understand, that so many people don't understand, that don't know about radioactive material, and it's what causes a lot of the fear with radiation. Is the difference between radiation, the energy, and contamination, getting material on me. Okay, so I like to use the glow light as glow stick as an analogy. That's what's inside there is the radioactive material, and the light is like the energy, the radiation. As long as that's contained, I can handle that glow stick, I can put it down, and there's nothing on me. But if that glow stick breaks open and leaks out, then that source of light, that source of energy is on me, on my hands, and then I can put the thing away, and then I'm giving off this light or this energy. So if I've got material on me, I can detect it because it's giving off that ionizing radiation. So just because you're exposed to radiation doesn't mean you're contaminated. When you go to the dentist or the doctor and you get an x-ray, you're not contaminated afterwards. A lot of people don't understand that. There was just this past week, there was a school that was closed in Pennsylvania because a kid brought a Fiestaware plate in as a Geiger counter check source, and somebody heard that it had uranium in it, and so they evacuated the school, brought in the hazmat team. So a lot of people just don't understand this stuff. When we talk about radiation measurement, radiation units, Roentgen, rad, and rem, are y'all familiar with those terms? Okay, we're going to get into more detail on each of those and what they mean. Measuring contamination, counts per minute, disintegrations per minute. Are you familiar with the difference between the two? When we would use counts per minute, so a lot of instruments read out in counts per minute, but when you talk about disintegrations per minute, what's the definition of a Curie? Anybody know?
It's like so many disintegrations per minute, but it's like 3.7.
Yeah. So 3.7 times 10 to the 10th, 37 billion disintegrations per second. You multiply that times 60, it's 2.2 times 10 to the 12th disintegrations per minute, so BPM. So contamination is often measured in BPM, and we'll talk again later in this course about how we can convert between counts per minute and disintegrations per minute. Okay, the Roentgen only measures X or gamma radiation. It doesn't really apply biological effects. The rad measures all types of radiation, but again, doesn't equate biological effects. So when we get into dosimetry, we'll talk in more detail about what all these are, and just trying to get a kind of a feel of a review of where you're at with a lot of this stuff. And then the REM is the one that equates biological equivalence. So we take a dose in rad, we can convert it into a dose in REM. Are you familiar with quality factors? Like each radiation has a quality factor. Have you learned that?
A little.
A little? Okay. So we'll go into more detail again when we talk about dosimetry stuff, you know, how good a radiation is at causing biological damage. That's that quality factor. Okay. So we've got these different Curie measures activity, the international units, the becquerel, rad, radiation absorbed dose, the international units, the gray, and then we've got the rem or the millirem and the sievert. So it gets confusing to a lot of people that are new to this because you've got kind of 3 units, Roentgen, rad, rem for radiation, and then those have SI units, gray, sievert, coulombs per kilogram for Roentgen, and then you've got the radioactivity that's Curies or becquerels for the international units. So it does get a little bit confusing. Oops. And then we've got a little chart, and again, this is all on Moodle here. So we talk about low risk versus safe. If you get a dose of 500 millisieverts, anybody know how many rem or millirem that would be? Close. Well, it's 50 rem. So that'd be 50 rem. So 50 rem, you'd see some blood changes. At 10 rem or 10 or 100 millisieverts, you'd see an increased cancer risk. And this is all stuff we'll learn in biological effects. You know, I'm just trying to get a kind of a feel for what y'all have gone through so far. And then these are the safe limits. The 5 rem is the limit for radiation workers that work at nuclear power plants. Typical CT scan is about 1 rem, 700 millirem for a barium enema. Your annual dose from natural radiation is about 300 millirem, and then a typical chest X-ray is about 1 millirem. Any questions on that stuff? Go.
It says here, rad is a measure of the amount of energy deposited per unit of tissue. Does it have to be tissue, or can it be a material?
No, it can be any material. So are you looking at the
slide on
the Moodle one?
Yes.
Yeah. So I actually noticed that. It's interesting you point that out. I was reviewing these last night because this was some of the material from I think the last time this was taught, and I saw that in there and I thought that's not right. So I'm glad you picked up on that, because that is not right. It's not tissue, it's any material. So the rad is able to measure energy deposited in any material, any radiation in any material. So very, very good catch there, Joe. So. All right. Well, this was just an exciting first day for me. Hope you all had fun. It's a short class. It's hard for me to kind of gauge.
Yeah, so the first quiz is due by Wednesday at 8 a.m. So don't put off, like, getting on your phone.
Is that, you put it due?
It's
Okay,
open, yeah,
all right.
it's open now, well, it opens at 10, I think, and then it closes Wednesday at 8.
Is there a class in here following Christie?
I have no idea.
So how many,
The labs, I don't.
how many of you have another class that starts at 10? Any of you?
I don't.
But
other people, I
Okay.
I think the next one starts at 12, that's why I wasn't sure, because I see one of stuff in here. I have to do my COVID test and then I'll bring it
Oh,
out.
okay.
So I'm gonna leave this stuff in here.
So Wednesday we'll meet in the lab.
Do you want them to change into their,
No.
okay, so
Street
you don't
phones
need
are
to
fine.
change Wednesday.
We'll get into that later in the media.
I took attendance on here. On my, so this is what it looks like if they, well, that's not true. They can't see, they only see this and this on their Moodle page, but those, and I just put the new ones on.
I know.
It didn't have the half-life slide.
How was your break, Amber?
Yeah.
Andrew, how was your break?
Are
I wonder if just the,
See, it went straight
uh,
from that one to that
well,
one.
if you do it in presentation mode,
Oh,
That's the difference because, so that slide is here.
okay.
So let me go into, so that's what it looks like.
Uh-huh.
And then if I go into presentation mode, it's hidden behind there. So it's not actually a different
Oh.
slide. It's just, it's presentation mode.
Okay.
So
I wonder if they can access it, if
Well-
it'll play the thing to them.
I didn't realize
Lynette.
people would follow along like that.
If you have the slides pulled up,
I had the slides pulled up, but I